Hello everyone, welcome to Sir's classes. This is Tushar Shaw, and in this video we will be continuing to solve JAM 2019 paper. Okay, that we were solving since the last quite a lot of videos. So yeah, so in the last video we completed up till question number 20. So in this video we will be solving question number so starting from question number 21. Okay, so among the question says that among the following compound the molecule having the lowest boiling point is. Okay, so yeah, so in the compound that are given are firstly let me just write down the name of the compound, that is uh, SnCl4, um, GeCl4, okay, SiCl4 and CCl4. Okay, now the normal trend is as you move down the like group in a periodic table, the due to the increase in size of the compound, that is from moving from C to Si to Ge to Sn. Okay, the size of the atom increases very high, and therefore the boiling point one must increase. Okay, and therefore the boiling point must increase. Now for the case for Si to Ge to Sn, this trend is followed. So so it is expected that Si would be having the lower boiling point, and then Ge then Sn. Now in case of carbon and Si, carbon is expected to have a much lower boiling point than that of silicon, but that is not the case. That is, CCl4 has a higher boiling point than SiCl4. Now why that occurs? Because CCl4 is always the C and Cl bond is very polar because of the high electronegativity difference. Okay, so in that case this results in strong molecular intermolecular forces between them. Okay, intermolecular forces is very high because the compound is very polar. Okay, now, Si and Cl on the other hand have electronegativity difference not that much, and obviously the size also is compared of Cl and Si is also very comparable. Okay, so in that case, the bond breaking the for breaking of intermolecular forces in case of SiCl4 is not that difficult. Okay, so Cl, so the order would be Cl would be having higher, then SiCl4, the SiCl4 would be having lower, then it would increase to GeCl4, and then it would increase to SnCl4. Okay, so this would be the order, but the order is not required over here. The question does just as the one having the lowest boiling point. So SiCl4 here would be having the lowest boiling point. Okay, so the option C has SiCl4 over there. So option C is the correct one. Okay, moving on to the next question. That is question number 22. Okay, so the correct option having the complex for each kind of following for each of the following pairs, which one is more reactive towards the oxidative addition reaction for the hydrogen molecule. Okay, so the oxidative addition reaction of H2 molecule is taking place in the complexes that is given. So let me draw the pair 1 over here. IR Cl and PMe3, 3 PMe3 are there. Okay, and in this case here would be I'm sorry, IrClCO, and here would be PMe3, and here would be PMe3. Okay, so in this pair, let us name this 1 and 2. So in this pair, this complex would undergo oxidative reaction much more, because here the PMe3 are like strong electron pushing groups, and therefore the electron density towards IR atom is in very high in compared to this, because this also has PM2 PM3 groups, but one CO group is there which causes back bonding. Okay, so the some electron density is pulled towards the CO molecule, and therefore this IR would be having less electron density in compared to this IR. Okay, so this would undergo oxidative addition in case of a with H2 much extensively than this one. So in this pair, I would be the more reactive. Okay, now drawing the pair 2, we have IR Cl CO PPH3 and PPH3. Okay, and in this case IR PPH3 Cl Cl Cl. Okay. Now in this case, firstly let me write this down. Okay. So in this case, firstly let me just explain this one. So here PPH3 is a strong like PPH3 because of the presence of PPH3 in IR, strong back bonding occurs between the like PP in the PPH3 ligand, and this the electron density of the IR group is greatly IR atom is greatly shifted towards the PPH3 ring. Okay. So this would here the electron density is reduced, and therefore this would not undergo the oxidative addition so severely. But in this case, though two PPH3 groups are there, because of the presence of CO group, there is a competitive pi back bonding like occurring over there, and therefore the extent of pi bonding in the PPH3 and the CO groups is then compensated, therefore making the electron density going nowhere except leaving the IR atom. Okay. So in this case, as the electron density is going not leaving the IR atom, therefore it would undergo the oxidative addition with H2 even more extensively than this one. Okay. So in this case also, this one would go this one would be going much more reactive, and this one would be having much more reactivity, and therefore the option that would be correct would be 1 and 3. In the options you can see that option A says 1 and 3, option A says 1 and 3, and therefore option A is the correct option. Now this has a reason, as this molecule is the such factors are working over there. This molecule is a special name given by the industrial chemist, and this molecule is known as Vasquez complex. Okay, Vasquez complex. Okay, moving on to the next question. That is question number 23. Okay, so it says the among the following the correct statement is. Okay, so we'll be firstly looking at each and every option. So firstly the density order is given, so CS, RB, Li, Na. Okay, so obviously this is not a density order because Li would be here and Na will be here. Okay, so this is wrong. Now the solubility uh, uh, yeah, so the solubility is asked. Okay, solubility order is given as CS2CO3, this is K2CO3, then this is Na2CO3, and then Li2CO3. Okay, now this order is correct. Why? Because this is firstly in the while going down the periodic table, we see that this complex this order is obviously followed: lithium, sodium, potassium, and cesium. And this would be more soluble than this one, because the size mismatch between the CS and the CS atom and the CO3 2 minus ion is very high. The size difference is very high, and therefore to stabilize the size difference and to stabilize the radius ratio of these two ions, what would happen is this would try to go soluble in water and get hydrated, so that the size mismatch can be equated. Okay, so in that effect is like compensated in this one, and then it is reduced in this one, and then it is reduced in this one. Okay, in Li2CO3, this is the least soluble in water. Why? Because there is hardly there is any size mismatch. The lithium ion is also small, and the carbonate ion is also small. Okay, so that is the case. So this order is correct. Obviously, if this option is correct, this is an MCQ question, so other options won't be correct, obviously, but we'll still check. Okay, so the ionization and potential is the order of lithium, potassium, sodium, cesium. This is also not correct because sodium would be here and potassium would be here. Okay, and the option D says melting point follows the order MgCl2, BeCl2, CaCl2, SrCl2. This also is not correct because this compound must be interchanged, and therefore option B is correct. So option B is the correct option B must be the correct option over here. Okay, moving on to the next question, that is question number 24. Yeah, the question number 24 is a kind of tricky one, because where is the question? Uh, yeah, so the question says reaction is given. Okay, here it is two Me groups are there, here one OH group is there, and here CH2 group is there. Now we give M, C, B, B, A. Okay, M per benzoic acid. I'm sorry, I get confused sometimes. Anyways, so what will happen is this on this double bond one oxygen would be added. Okay, simple oxygen epoxide formation. Here would be one OH, and in this case CH2, here would be one O formed. Okay, now what would happen is, uh, yeah, so this oxygen lone pair would fall over here, and group would be attacking over here. Okay, and therefore this bond will be opening. Okay, I'm sorry, not this one. This bond will be opening. The CC bond, why will the CC bond be open? The C and O bond will be opening. Okay, and obviously this oxygen would be catching up this hydrogen, so I am directly drawing the rearranged product. Okay, uh, and here will be the CO2H. Okay, so if we just arrange this properly, we may write it as, okay, we may write it as this one. This is OH here, and here is double bond O with the two methyl groups over there. Okay, so in the options you can see that option B is this option, this product that we have got. Okay, so option B is the correct one, the product. Okay, moving on to the last question of this video, that is question number 25. Okay, this is a kind of easy question because yeah. So NMR is obviously easy for me because you have obviously noticed that when I do NMR questions, NMR is quite kind of easy for me because it is the like for me I am doing my masters in organic chemistry, and for me the NMR chapter is like my favorite. Okay, so the most expert I'll be in fact I'll be doing my PhD also in this NMR topic, so spectroscopy. So that is it. Anyways, so the molecule which is given is HZ, then here it is HY, and then O is there, and C, H3, X is there. Okay. So the correct order of the chemical shifts of the label proton HX, HY and HZ is, okay. So we have to like determine the delta values, the delta values in ppm, which we all obviously not, we have to not determine, we have to just give the order. Okay, which delta value for which hydrogen would be greater and which one would be smaller. Okay, so in this case you can see that this hydrogen is both in contact like in close proximity of an electronegative O atom and the sp hybridized H atom carbons. Okay, so this would be like heavily deshielded and would be having the highest delta value. Then this hydrogen would be like this X hydrogen obviously would be having then more like the delta value after that, because this H is in close proximity with an electronegative O atom. Okay, and the last would be this HZ1, which is just in close proximity with the sp hybridized carbon, so not so electronegative group is in the close proximity, and therefore the delta values would be like less comparative compared to the other H atoms. Okay, so the order will be Hy will be greater than Hx and then Hz. Okay, and in the options you can see that option D is the this is the order that we have right. So option D is the correct option. Okay, so yeah, so let us wrap this video up. We'll see you guys in the next video. Thank you.